Good afternoon, everybody. How are you all? Today we are going to talk about two sample hypothesis test when population standard deviation is known. Okay, so let's go to the PowerPoint. To sharing my screen. 100 students from a state university and 100 students from a private university are randomly selected and surveyed. The researchers wanted to determine if the state university students took longer time to complete a 4-year program. The state universities took um, an average of 4.5 years, and private university students took an average of 4.1 years to complete a 4-year program. The population standard deviation for state university is 1.5811, and for private university is 1 year respectively. Test the hypothesis at the level of significance equal to 0.05. Okay. So here we go. Solution. Since we know the population standard deviations, we will use two sample Z test in TI-84 calculator. Okay. So let 1 is equal to state university students, and let the 2 is equal to private university students. So the researchers wanted to, what did it say, the state university? So the researchers wanted to determine if state university students took longer time to complete 4-year program. So the alternate hypothesis is mu1 greater than mu2. Okay. And the null hypothesis is mu1 could be equal to or less equal to mu2. Okay. Remember, the null hypothesis always contains the equal to sign. So let me create some more space. This here and go back to this one. Okay. So data given. So let's go with the given data. Given x1 bar, the average time taken by state university students to graduate is 4.5, and the population standard deviation for state university is 1.5811. N1 is equal to 100. For private university student, the sample average is 4.1 year, and sigma 2, this is sigma 1, of course. Sigma 2 is equal to average of 4.2 complete the population 1. Okay. And N2 is also equal to 100. Also, level of significance is alpha is 0.05. Remember, this is the maximum probability of rejecting 80 when it is true, of rejecting 80 when it is true. It is true. When it is true. Okay. So let's create some space for us. Okay. So we are going to use two sample t-test and z-test, two sample z-test, not t-test, z-test, because we know the population standard deviations. Okay. So we go to the calculator and press, so what do we do in the calculator? I'll write out the steps. Stat, oops. So let me move up a little bit more also. And then we go press the calculator stat button, then highlight test on the top row. Highlight means move the cursor on test, the black rectangle. Then scroll down to, with the down arrow key, to sample z-test. Again, we are using z-test because we know the population standard deviation. Z-test. Okay, and hit enter. Okay, the first line input should be on stats. Why? Because we know the summary stats of the samples for both 1 and 2. Okay, sigma 1 is for the state university students is 1.5811. So type in 1.5 stat test to sample z-test. Scroll down to sigma 1, 1.5811. Sigma 2 is the standard deviation of the private university students is 1. So type in 1 for sigma 2. For x1 bar is 4.5. Okay. N1 is 100. Okay. So next line is N1 is 100. Okay. X2 bar is x2 bar is 4.1. 4.1. N2 is 100 again. 100 again. The next line is the alternate hypothesis. But before we do that, I'll create some space. Okay. N2 is 100. Then the next line is the alternate hypothesis. Mu1. Okay. And we know our alternate is mu1 greater than mu2. So put the cursor on greater than mu2 and hit enter so that it's flashing on greater than mu2. Flashing. Okay. And then we scroll down to calculate. Okay. And hit enter. Okay. So we are looking for two things. Test statistic, Z, this is your test statistic. That is, we are comparing the difference in the sample mean x1 bar minus x2 bar in terms of the standard deviation of the sampling distribution of the difference in the two sample means. And that z-test statistic is equal to 2.138. That means x1 bar is greater than x2 bar. The sample mean of sample 1 is greater than the sample mean of sample 2 by 2.138 times the standard deviation of the sampling distribution of the difference in the sample means. Okay. Next, we look for the p-value. P is equal to 0.016. So p-value is the probability of getting probability of getting a test statistic as extreme as 2.138. Now we have been given, alpha is equal to 0.05. So P is less than alpha. Decision reject 80. Conclusion at alpha equal to 0.05. There is enough evidence to support HA, which is mu1 greater than mu2. Okay, let me take care of this line by erasing this. Okay, so that means we are rejecting the null hypothesis mu1 equal to mu2 and supporting the alternate that mu1 greater than mu2. Okay, so if we do it another way, let me see if I can do it another way. Okay. Okay. This whole problem can be done in another way also, which I will show you next. So I will move the screen a little bit up. Okay. And we'll go back to the pen and the color of the ink to blue. Okay. Another way to do the same problem. Way to do the first one, we calculated the p-value for the test statistic, compared the p-value with the alpha value, p-value less than alpha, we rejected the null hypothesis. Another way to solve the problem. Okay. Remember, our null hypothesis is mu1. I'll start with the alternate. Mu1 greater than mu2. And null hypothesis can be mu1 less equal to mu2 or equal to. It does not matter as long as it contains the equal to sign. Okay. We already know the data. So now what will we do? To the other way to do the one. Press the stat button. And then the test button, then highlight the test on the top row. And scroll down. So down, instead of scrolling down to 2 samples Z test, scroll down further to go down to 2 sample Z, 2 samp Z int. Now samp is the short form of sample and Z is the int is the short form of interval. So basically we will construct a 95% confidence interval for mu1 minus mu2. Okay. 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 Now, okay. So once we are in two samples, Z int, hit enter. So bring your cursor down to number 9, two sam Z int, and hit enter. Okay. Again, same as before. Input should be on data because we know the sum. No, input should be on stats, not on data. Stats because we know the summary stats for the two samples. Sigma 1, these are already appear if you've just done the problem. 1.5811. Sigma 2 is 1. X1 bar is 4.5. N1 is 100. X2 bar is 4.1. N2 is 100. And C level, because our alpha is 0.05. Remember, C level is the complement or opposite of alpha is 0.95. It's already in the calculator. And then we will calculate. Okay. Should I create a little bit more space? So we bring the cursor down on calculate and hit enter. And the 95% confidence, and we get the answer 033, 0.767. What does it mean? With 95% confidence, we can state that the actual value of mu1, minus mu2 will fall between 0.03 and 0.07. I mean 0.77. Remember our null hypothesis. 80 was mu1 minus mu2 equal to 0, and alternate was mu1 minus mu2 greater than 0. This is same as saying 80 mu1 equal to mu2, and HA is mu1 greater than mu2. Okay. So the 95% confidence interval, for mu1 minus mu2 does not contain 0. It starts from 0.03. Therefore, we can reject 80. Okay. And at alpha equal to 0.05, we can support HA, which is mu1 minus mu2 greater than 0. So if the 95% confidence interval does not contain the hypothesized value, in this case 0, of the difference in population means, then we can reject the null hypothesis and support the alternate hypothesis. This is another way of doing the same problem. I'll stop here today. If you like my video, please give me a thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. Thanks for watching. See you next time.